Hey, what is up, guys, and welcome back to the exercises part of the section 1 of chapter 2 of the course. If you watched the previous video, I mentioned that after doing the readings, I'm going to do a separate video covering the exercises that correspond to this section of chapter 2 on programming terminology. Now, we did run into an issue because I have already recorded the video of me covering these exercises just like a few minutes ago. But when I went back to rewatch it, the frames were going insane. The audio was cooked. So I have to redo these exercises on video again because it was kind of weird to just pop up into the next video and it's just me covering the next topics and just me saying, oh, hey, by the way, I did the exercises, solutions are up, go to the solutions, when I can just do these exercises again on video and walk you through my train of thought as we're doing them. So I apologize. As you can see, all three have already been done, but I went back and reset them, but they still look like they've already been evaluated even though I've already submitted a reset. So these don't count yet, but the UI, I guess, hasn't updated or whatever. So it still shows that I've already completed them. So I'm gonna walk you through these three exercises. They're pretty quick, and then we'll move on to the next content in the course. So this first exercise is called Fix the Syntax. It says the following program contains several syntactic errors, and if you remember from the previous videos, syntactic errors basically means missing semicolons, missing quotes, quotation marks, stuff like that, incorrect data type mismatch when you're doing operations, stuff like that. So it says, please fix the program so that the syntax is in order and the program works as specified by the examples below. So here's how the program looks. It's going to ask us to type in a number. It's going to evaluate that number if it's greater than 100. Then it's going to print that the number is greater than 100. Then it's going to subtract 100 from that number. Then it's going to print the value has decreased by 100. And then it's going to print out what the updated value is of the number. And then it's also going to print that that number is your lucky number, and then have a nice day. So these are sample inputs. So here, if we plug in 13, it says 13 must be my lucky number, and then have a nice day. Here, if we plug in 101, it says the number was greater than 100. Then it does the subtraction. It says now the value has decreased by 100, and then the value is now 1. And then it does the final blank must be my lucky number, and then have a nice day. Okay, so this is the program. So this is how it's supposed to run. If we plug in a number smaller than 100, it just prints out that it's the lucky number and have a nice day. If the number is greater than 100, it does all this stuff and then prints out that it's your lucky number and then have a nice day. So in this one, what we can do is kind of just let Python walk us through what the problems are. If you quickly scan it, you can probably see what the problems are. Here we have some indentation errors. So this should be all the way to the left, same as this line. We're missing a colon here. The value from the evaluated expression here isn't being stored anywhere, so it's kind of just floating in the air. Again, another problem, missing with the indentation here. And same thing down here. Here we also have another problem because this is supposed to be a number, right? So another problem here is we haven't converted the input into an integer. So this is supposed to be an integer, and when you do an integer plus a string, it's not gonna concatenate. It's gonna Python's actually gonna try to evaluate if 100, what 100 plus a string is, and it's not gonna be able to do that because of the data type mismatch. So these are just some of the errors you can quickly see when you are just looking over the program. So let me click run here, and we get the first error that Python spotted for us. It says indentation error on line 2, unexpected indent. So this is the problem. We're just going to hit backspace on our keyboard. Let's hit run. We'll get another indentation error, this time on line 3. Same thing, just hit backspace. I'm also going to add a new line here just to give our statements here some breathing space. Hit run again. It says line 4, invalid syntax. we're missing a colon here, like I mentioned before, and I'm just gonna add a space here and a space here, make our code a little bit more legible. Hit run. Syntax error on line 7, end of line while scanning a string literal. So let's find line 7. It's a print statement. It says print now its value has decreased by 100. So we have an opening double quotes here, but we're missing a closing one, so that should fix that error. Hit run. Now we have another error, indentation on line 8, unexpected indent. Again, this is nested. It shouldn't be because it has no, the code here doesn't have a colon. It's not an if statement. It's not a function block. So just fix the indentation here. In fact, we can actually just do this, right? Just put all of that back. Okay, run again. It says indentation error on line 9. Unindent does not match any outer indentation level. So this is, instead of a tab space, they use just a single space on the space bar. But these two lines are always printed, as we can see from my example. It prints the number, must be my lucky number, have a nice day, same thing here. So these don't even belong in the same indentation level as this print block. Gonna add white space here. And so that should fix this error. So now, again, we have another error, syntax error on line 11, end of line while scanning string literals. We can expect it to be the same problem. We're missing a double quotes here. Okay. Run it again. So now the program is executed. So did we fix all the problems? Let us see. If we plug in 13, another error. This is a type error on line 4. The greater than evaluation is not supported between the instances of a string and an integer. So right now, whatever value the user provides is stored into the number variable, but it's not stored as an integer, it's stored as a string. So here Python is gonna basically do is number, the string number, greater than integer 100. And obviously, this is a data type mismatch for evaluating Boolean expressions, right? It's either going to be string and string or a string and a number. A number and a number. So we're just going to have to come over here and wrap this input function in the int function that will typecast the string into an integer. So let's run this again. Let 13. Now we have another type error on line 10. It says unsupported operand type for addition, integer, and string. And this is on line 10. So if we go to line 10, we see print number plus this string. So, right. So this Python here is just evaluating this, right? It's evaluating number, the integer plus the string. So we want to concatenate here. We don't want to do an actual expression evaluation. So what we can do one of two things. And I'll duplicate this line just for you to see. So first what we can do is wrap this in the string function, which will typecast this integer back to a string. That way we can concatenate them. So now this will be the string 13 concatenated into the string my lucky number. Must be my lucky number. So this will work. Or you can just convert this whole thing into an F string like this and just say number must be my lucky number, and then this one will also work. So I'll actually comment this out, and we'll do this one first, and then we'll do this other one so you can see it actually working. So let's do run. And we have one more problem to fix, but again, we're just going to let Python walk us through the problems that it notices. So 13. So now it works. 13 must be my lucky number because 13 is not greater than 100, so this is not going to get evaluated. There's still two more errors here that I'm already spotting that we're going to be able to fix. I'm going to comment this out and comment this. Again, just do 13, and again, it works. So you can do this way, or you can do this way. I'm going to leave this here. I'm going to leave both of them in, but I'm just going to comment this out. When I upload the solution, you go and check it out. I'm going to leave a comment here. You can print out the next line in either option. So if you're just reading the solutions and you don't want to be bothered by watching the videos, you can see you can do print this or print it this way using string concatenation or F strings. Okay. So now, if we run this with a number greater than 100, so 101, we get an error. The number was greater than 100. So this first part works, right? 101 is greater than 100. So the if statement now, all the statements inside the if block are going to be executed. So we executed this, printing the number was greater than 100 right here, but we get an error. It says type error on line 8 can only concatenate strings and not integers to string. So this error is another problem. Same thing, we're concatenating number to this string instead of making sure that this is converted to a string like that. And I'm gonna add a space here. So you can do it this way, and you can also do it the F string way like I did down here. But for the sake of actually legibility and having everything flow, we're just gonna do it this way for both of them. But you can do it this way, or you can do it this way. You can do the F string way, or just converting this to a string and then concatenating this string. So we're not going to deviate too far from what the original function program was already written as. Okay, let's learn this one more time, see what we get, 101. And now it's running completely. It says the number is greater than 100. Now its value has decreased by 100. But it's printing that its new value is still 101. And then it says 101 must be my lucky number. So what gives? Right here, right? So we're doing this expression here, we're evaluating this expression, but we're not saving whatever value is being returned into a variable. So we can do one or two things. We can do number minus equals 100. So it's like an inline here instead of doing, which is the shorthand way of doing number is equal to number minus 100. So I'm gonna leave it like this because it's a little bit more legible. But if you want, you can do it the shorthand way of just doing number minus equals 100, like that. All right, cool. Oh, pardon me. So now, if we run it again, do 101, and now our program works. It says the number is greater than 100. Now its value has decreased by 100. Its value is now 1, because 101 minus 100 is 1. And then it says 1 must be my lucky number, and then have a nice day. So if you run this through all the tests, we pass. Awesome. And if we look at the model solution, it's same thing that we came up with. So they also did wrapping the number into a string to do the concatenation. Same thing here. But again, like I mentioned, you can just do F string or do this way by typecasting. Okay. Next exercise, this is called number of characters. It says the function len can be used to find out the length of a string. Among other things, the function returns the number of characters in a string. Some examples of how this works. Word is equal to string ABCD. Then we print length of word. And here they're printing the length of this string, hi there. Then here we have another word manually set as howdy doody. Then length is equal to evaluating the length of this string. Then we're going to print this length, and then we're going to reuse it down here for this empty string. So first word, ABCD, has a length of 4 characters. This string has a length of 8 characters. Howdy doody has a length of 10 characters, and this empty string has the length of 0 characters. It says, please write a program which asks the user for a word and then prints out the number of characters if there was more than one typed in. Examples of expected behavior. If we type in the word hey, it says there are 3 letters in the word hey, and then prints out thank you. If we type in banana, it says there are 6 letters in the word banana, and then prints out thank you. But if we type in just the letter B, it just goes straight to printing thank you. So we know that at the end of this program, we must print out thank you. Regardless of what happens before it, thank you has to be printed. So we're going to have a variable here called word, which is going to track the string that the user provides. So please type in a word. Then we're going to have a variable that tracks the length. And this is just going to be using the length function. And we're going to pass word as an argument. So this is going to store the length of whatever word that we provide. And we don't have to do any typecasting here. We want a string. We're going to leave it the same way. Length is clever enough so that it's just going to evaluate the length of a word without us having to do any typecasting or changing the string into any other data type. So this is pretty simple. We're just going to say if length is greater than 1, then print, we're going to use f strings, there are, then we're going to say length letters in the word, and then we're going to pass word here. So if we run this and we type in hey, it should say 3, awesome. If we type in banana, it should say 6 letters, awesome. And if we just type in the letter B, it should just say thank you. Test. Passes all our tests. We can view the model solution. Same thing. Have a variable that tracks what the string we input is. Have a variable that stores the length of that string. Then we ask if length is greater than 1, then print out the length. They did it this way with using the comma separated values. So we put a string, comma, whatever we want to be printed, then comma, then more strings, and then at the end here they did this concatenation, which is, I guess it's fine, but I would have liked it if they just stayed it with the same format. We kept it simple. We used f strings and just printed it out like that, and then at the end we printed thank you. Okay. Now this one is called typecasting. It says when programming in Python, often we need to change the data type of a value. For example, a floating point number can be converted into an integer with the function integer. So temperature stores a float, and then we print that temperature like that, and then we printed out the rounded down version of it using the integer function. So it says please type in the temperature. We provide 5.15. So the temperature is 5.15, and rounded down, it is 5. So notice the function always rounds down, and not according to the rounding rules in mathematics. This is an example of a floor function. Please type in a temperature 8.99. The temperature is 8.99, and then rounded down, it is 8. So even if we're supposed to round up to the nearest tenth, or to the nearest integer, using the integer function, it rounds down. So 8.99, instead of becoming 9, becomes 8. It says, please write a program which asks the user for a floating point number and then prints out the integer part and the decimal part separately. Use the Python integer function. You can assume the number given by the user is always greater than 0. And then here an example of the expected behavior. So it says, please type in a number, 1.34. The integer part 1 is 1, and then the decimal part is 0.34. So we know that we need to store a floating point number. So we're just going to say variable number is equal to float, which is the casted data type from this string. I'm going to prompt the user, please type in a number like that. And then here we're going to get the whole number. And it tells us that we need to use the Python integer function. So if we write here a variable called whole int number like that, because we know, for example, if we plug in 1.34, the integer function is going to round down for us and give us a whole number. So 1.34 is going to become 1. So this is what this is doing. So whole is equal to integer number. Then to get the decimal part, it's pretty simple. We're just going to have here a variable called decimal, and we're going to do the whole number, number minus the whole. So if number is 1.34 and the whole is the rounded down integer, so 1.34, what we're doing here is just 1.34 minus 1. Then we can do print integer part whole, and then print decimal part, and then decimal. Now if we run and 1.34, we get 1, and here we get 0.340000. And I think so that should work. If we hit test, we passed all the tests. We can view the model solution. And they did pretty much the same thing. So a number is this float that we plug in. The integer part is just wrapping the number in the integer function. It's going to return a whole number, the rounded down number. Then to get the decimal, we just do number minus the integer part, and then we just print them out. So that's it. These are all pretty straightforward, pretty simple. If you have any questions, you can leave them in the comments below. These solutions will be posted up in the part 2 folder of the GitHub repository that I have that stores all my solutions to these exercises on there. The link is in the description. Please go give it a look. And please leave a star. I'll actually open it right here. It's right here. If you can, give it a star. It really helps me out knowing that people are following along with me. This is the repository. Still got to do a little bit of editing. But so far, I have the first 8 solutions from part 1 up. I'm going to upload the remaining solutions from part 1. And if people want, I can divide them into each section from part 1, if that makes it a little bit easier to follow along. If not, I could just leave them as just one long list of solutions. And I'm going to create the part 2 folder. It's going to sit right below here. It's going to have the solutions to part 2 that we have up so far. So thank you so much for tuning in. Make sure you go check this out. Give it a star. Again, you can just click here, star. It truly means a lot. Again, it just lets me know that people are following along and they're enjoying the content and are also, taking value from the solutions that I provide. So thank you, and I will see you in the next video where we're going to be covering section 2 on more conditionals.